In this video, we're going to talk about aggregate functions and queries that group together results. Aggregate functions and grouping are often used together to summarize data by getting totals, finding minimum and maximum values, or getting the number of rows that meet a set of criteria. Problem 1. Using the aggregate function count, write a query to find out how many rows are in the appointment table. This query is simply using the count aggregate function to get the number of rows in the appointment table. Notice we're passing an asterisk to the function to indicate all rows. So the result would be 52 rows because there are 52 rows in the appointment table. And this is a very simple example, but of course we could add a where clause to this function if we wanted to find the count of rows in the table that met some specific criteria. For example, we could have select count from appointment where doctor staff ID equals 1102. And the results of this query show us the number of appointments where the doctor 1102 is assigned as the staff member. Problem 2. Using a group by clause, write a query to find out how many appointments each patient has in the appointment table. You do not have to worry about patients that have 0 appointments. They do not have any records in the appointment table. This query uses a group by clause to group the results by patient ID. So when we look at the results of this query, we have one row for each patient, and since we're grouping by patient in our count column, we'll get the total number of appointments that patient has, the number of rows that patient has in the table. So if we scroll down, we'll see most people have 1 appointment scheduled, but a few have 2. And there are 46 rows in our results. So now we know that 46 patients have 1 or more appointments scheduled in the database. Problem 3. Write a query to select the number of appointments that have a non-null bill amount, the minimum bill amount, and the maximum bill amount. So here's a statement that gets the number of all the appointment records where the bill amount is not null, and it's also selecting the minimum bill amount using the min aggregate function and the max amount using the max aggregate function. Problem 4. Write a query to select the average bill amount for appointments that took place before December 9th, 2014 at Beachview North, appointment site 4, that were handled by the staff member with ID 1102. This query is similar to the one we wrote before, except we're just selecting the average bill amount using the average aggregate function, AVG. So we can see that the staff member with ID 1102's appointments at Site 4 before December 9 have a bill amount averaging $30. Problem 5. Write a query to find the total number of bills and average bill amount for each city in which patients live, but only for those cities that have 5 or more bills and the average bill amount is between $150 and $300. Sort by city. Here's the solution. We're selecting the count of all the bills, the average bill amount, and the person city field from the appointment table, interjoined with the person table, where the patient ID and person ID match up. And then we're going to say group by person city. Group by is a clause you can use when you're using aggregate functions, and it will take your query results and group them by the field you specify, and the having clause lets you define criteria for which data are returned by your aggregate functions up in the select statement. You can add one or more criteria in the having clause, so you could add to or take away from this clause as needed. For example, you could remove the and average bill amount between $150 and $300, or you could add another statement after this. In this case, we want the cities where there's a count of 5 or more bills, and the average bill amount is between $150 and $300. So when we look at the results of this query, we'll see that there are 5 bills in the database for patients who live in Cropsville, and they average $150. There are also 5 bills in the database for patients who live in Skysville. They average $221. Problem 6. Write a query to find the maximum bill amount for each doctor at Flootstown Walk-In, appointment site 2. Alias the maximum bill amount column as M and order by M. To get the maximum bill amount for each doctor at Flootstown Walk-In, we select the doctor staff ID, the max bill amount, which we alias as M per the problem, from the appointment table, where the appointment site equals 2, which is the appointment site code for Flootstown Walk-In, and we group by the doctor staff ID, and then we order it by M. So what we end up with is 3 records. The staff member with ID 1030's max bill amount is $50. The staff member with ID 1112's max bill amount is $150. And for appointments that weren't assigned a doctor, so null, the max bill amount was $75. Problem 7. XYZ Medical Group is considering giving a 10% discount on all existing bills at one of the 6 sites. They want to know which site would lose the least amount of money by giving the discount. The site must have at least 7 existing bills to give the discount. Write a query to get the appointment site code and name, number of bills for each site, the total dollar amount of the bills for each site, and the total dollar amount for each site with the 10% discount applied, and the difference between the total and the discounted total for each site. Use column aliases as appropriate. Which site has the lowest difference? To write this query, we just need to select from the appointment table, and we group by appointment site, having count of greater than 7, because we want to get the information for each appointment site with at least 7 existing bills. We're selecting the appointment site, the count, which I've aliased count, the sum of the bill amounts, which I've aliased as sum. The sum of the bills, if we discounted them, would be 90% of the sum, so we select the bill amount times 90%, aliased as discount. That's what the total of bills would be if we applied the discount. And then we select the sum of the bill amounts minus the discounted sum, aliased as difference. That's the amount of money that site would lose if they were to give a discount. So we can see that site 5 has the lowest difference. They would only lose about $37 by giving the discount. So we would recommend the discount be given at site 5. Problem 8. Using the max function, find the last name in the person table that is closest to the end of the alphabet. This one is really simple, and you can just use the max aggregate function to select the max person last name from the person table. And you can see that the answer is Wang. So we don't have anyone whose last name starts with XYZ in our database. Wang is the closest name to the end of the alphabet. That's it for now. See you next time when we look at subqueries.